answer. Uh, so this video is an introduction to business statistics. Now, this is the course that I wanted to introduce to you this week. I know you've been quite busy traveling outside the country and moving up and down. Can be quite busy, and I understand that. On Tuesday we tried to do our session online, but it couldn't work out, so I still decided to go ahead and just do a recording of this course or this topic, the introduction in particular, so that you can be in the loop. I don't want us to go for a long time without having any sessions. So it could go dry, and maybe you may start forgetting some of the things that we are covering. So I've made this video so that you can just keep yourself updated wherever you are at your own convenience. You can watch it anytime. Now, the mood was supposed to be online. We were supposed to have it on Zoom, Teams, or Google Meet, depending on whichever is most convenient for you. The online session have been much better because they have given us an opportunity to interact, you to ask me questions, me ask you questions, we get to interact. You also have your own additions, subtractions, and things like that. But because of the schedule and everything, I understand it's a bit tricky. So when you come back, perhaps we can have it online. We can have it. We can have a physical session back at your place in Ibex. Uh, I'm not exactly I'm not exactly going to explain much in this video. It's an online video, recording in fact. So I'm just simply trying to introduce this course to you. It's just basically explanations, not too many mathematics or anything like that. Now, yeah, as you already know, my name is Kay Machacha. Now, the session is just introduction to business statistics. So yeah, let's dive into the course itself. We'll begin with defining what statistics is. Now remember, the course is business statistics, but for us to understand business statistics, we have to first of all understand what statistics is. So this is exactly what we'll be doing in this first slide, understanding what statistics is. Now, according to a simple definition of statistics, we say it is the science of collecting, organizing, analyzing, and interpreting data. So one is collecting, two organizing, third analyzing and interpreting data. So data could be about a lot of things, literally anything that you can think of. You can collect data about that. It could be the sales. Let's talk about business. It could be the sales that you're making in a business. This is Friday. So from Monday to Friday, you've probably been selling. You want to know how many things did I sell on Monday, how many things did I sell on Tuesday, how many things on Wednesday, and so on. So that's data that you're collecting. It could be the number of people that perhaps are staying in Ibex. You could say so. How many people are staying in Ibex? So how many people are using Twin Palms Road? So you could stand maybe at the road and check how many people, how many cars are passing through Twin Palms Road. That's data. You're collecting data to analyze. Maybe you want to construct a road, so you're trying to understand how the traffic moves. Is it a traffic that will probably be best suited for a dual carriageway or so? Yeah, data is just anything, and statistics, we apply it to almost in fact, everything about life. It's applied in the physical sciences such as physics, chemistry, biology, engineering, all those things. Medicine, you apply statistics in all those things. It can also be applied in business, like I was describing about the sales that you're making. You could want to track your profits over the past 3 years. You collect data. So the first thing is you collect it, you organize it, you analyze it, Then you have to interpret that data to see if it's making sense. What is this data trying to communicate? Perhaps about the business, or maybe perhaps about the nation. So you'd collect census data, number one. You'd collect the number of people in Zambia, get how many are female, how many are male, how many are in which age gaps, and things like that. And then you have to organize that data. You put it properly. You organize it. Okay, female, it's this, male, it's that, things like that. Then you have to analyze it. You look at the data. Okay, how is the data flowing? How is it related to itself? How is it moving and things like that? How has the male population been moving over the past few months, perhaps? So has it been growing? Has it been reducing? Then you interpret the data. This is now making sense of the data, or this is where you come up with conclusions. So, okay, in Zambia, the male population is dying slowly, things like that. So, why do we use statistics? Statistics helps us make better decisions based on facts and not guesses. So we don't want to base our decisions on guesses, but we want it to be on facts. For instance, if you want to know, let's say you run a boutique store, you sell shoes, you sell uh, let's say trousers and t-shirts. You sell these three things. Now you have some capital, perhaps an investor has given you some money, and you want to know, what should I invest more in? What should I buy more of? Should I buy or stock more of shoes? Should I stock more of trousers, or should I stock more of t-shirts? For you to know, you don't just guess. You need some facts. You need data to guide your decision making. So what you do is you collect the data on shoes. How have shoes been performing? How have I been selling shoes? How have I been selling trousers? How have I been selling t-shirts? You check over time the profits that you've been making on shoes. How quickly are you able to sell shoes? Same thing on trousers, same thing on t-shirts. Then that will guide your decision, knowing, oh, okay, let me invest perhaps maybe in shoes. Shoes are more profitable. It's based on facts. Why? Because you've analyzed your data, you've made sense of some data, you've applied statistics to help you make a better decision based on facts and not just guessing. It could also apply on a country level. The government wants to know, what should we build more of? Should we build more of children hospitals? Should we build more of male facilities? I guess in hospitals there may be male facilities that are particularly for male, perhaps are dealing with male issues. Then they may be also, I know gynecologists are focused more on women. So the government may want to know, what should we invest more in? What should we build? They have to undergo this process of statistics. They have to collect, organize, analyze, and interpret data to guide their decision making. Okay, how men are suffering the most? Perhaps it's male. Okay, let's invest more in male. That comes from statistics. An example would be a shop owner who tracks how many t-shirt sales per week to know which sizes and colors to stock more of. When you're selling t-shirts, I have an opportunity. I do a business, a small. I used to do this while I was back at Unza, where I was selling some clothes. So sometimes people want different. I was selling bottoms. They are branded bottoms. Adidas, Puma, there is Umbro, there is Nike, all these things. And there is also Jordan, all these branded bottoms. So many times I would sit down after making my sales. I would check, what are people buying the most. I would discover that people would be buying uh, they would buy more of Nike. I think most people love Nike. I don't know why, but many people enjoy Nike. The second one I think is Adidas. People buy Adidas. I think it goes well with the slides, the Adidas. But the color also mattered. I realized that many people were buying dark colors or darker colors. So dark blue, black was the best seller, gray. If you bring something fancy like yellow, red, things like that, many people wouldn't buy. So I'd collect the data to know what should I stock more of? That was statistics in play. So the beauty about statistics is that it's almost in every aspect of life. Almost in every aspect of life. Uh, Now we come to business statistics. We've described what statistics is. Now, what is business statistics? Business statistics is just statistics, but then we are just applying it in business. That's all. It's the application of statistics in business decision making. It's as simple as that. You just apply the principles of statistics in business. Uh, how do we use business statistics? We use it to analyze sales and profits, forecast demand, measure customer satisfaction, control quality in production. So, you just is analyzing sales and profits, basically just collecting data. You check how many things you sold, the revenue, you negate your costs, you find your profits and the like. Forecasting demand. You forecast demand. For instance, if you sell cars on Monday, Tuesday, Wednesday, Thursday, and Friday. If you sell two cars on Monday, Tuesday you sell four, Wednesday you sell six. You can forecast, let's say today is a Wednesday, you can forecast to say, okay, I think Thursday I'll probably sell eight, and Friday I'll probably sell 10. So you are this day, you've checked your previous sales, you want to know the next 2 days. You just look at the trend. You will use statistics for that, and then it can also be used to measure customer satisfaction. You can also do control quality in production. We'll get more into these uh, into more detail for these two as we go throughout the course. Next up, I want us to look at why business statistics matters. First of all, it helps businesses reduce risk. The example I was given of you trying to know what to stock more of. You're selling shoes, trousers, and t-shirts. What should I stock more of? You have to use business statistics to analyze your sales for each of those three things. So to know which one is selling the most. If you've been given capital, perhaps you've gotten a bank loan, you want to know what to invest more on. You won't just make a guess because that's a risk you're making. You have to make a decision that puts you on a safe side. So you analyze your data. You will say, okay, how have my sales been? Do I expect to make money? And things like that. It improves planning and forecasting. So planning could be you can perhaps correct your sales. Let's say you sell ice cream, right? You sell ice cream. Ice cream, what you notice, if this is a graph, these are sales, this side, plotted against months. So this could be January, February, March, April, May, June, July, August, September, October, and December, and November, and December. Ice cream sales in January, they are not very high, maybe somewhere there. In January, you could expect somewhere there. In February, maybe they go a bit because February gets a bit hot. March, maybe a little there. April, not so much there. May, it starts getting cold. People don't buy ice cream as much. June, obviously, you expect your all time low. People buy less. In July, still buying less. As you go to August, you see, okay, people start buying a little bit more. September, people buy more. October, obviously, expect October to be the highest. People would buy somewhere there. So it gives you sort of a graph like that. And then December, same like that. Uh, when you collect, that's what I've been doing here. You collect your sales for January, sales for February, sales for every single month, and then you plot them like that. That's statistics that you are using to do all this. So it could help you know when business is the best somewhere here. So you would want to invest more in your business, maybe in this period somewhere here, because your business is going to boom. So you want to stock more on your ice cream cones, your cream, and whatever is used in ice cream production. If you invest perhaps somewhere in here, it should be, this is May. You invest a lot, you buy a lot of stock to create ice creams. You would make losses because in June, as you go in these months, your sales are about to fall. So if you don't know statistics, if you don't have statistics, you can't know this. You'll be making guesses in your business, which will probably uh, uh, kick you off business. So it's very important. Statistics is very important. It helps in planning and forecasting. Forecasting just simply telling what will happen in the future. So it could be based on this graph. Oh, okay, sales will go a bit high, they will drop, and then they'll go their all-time high. It supports evidence-based decision exactly. So as you are choosing to not to invest here, you show evidence. So okay, sales usually increase in October, so I'm going to invest more somewhere in August. So as October is reaching, I make a lot of money. An example would be a farmer studies past crop yields from the last 3 to 5 years to plan what to plant next season, how much fertilizer to buy. This is exactly it. You sit down as a farmer, you check in the past somewhere 3 to 5 years, how have my crops been performing? And then that will tell you what to plant next season and how much fertilizer to buy. And then let's talk about something that's very, very important. You need to know that there are two types of statistics. We have descriptive statistics and inferential statistics. Descriptive statistics is all about summarizing or describing data, and then inferential statistics is uses data to make predictions or conclusions. Now, I'll explain it in this way. Uh, if perhaps you get the population of the people in Lusaka, right? You get people in Lusaka. This is Lusaka city. I think Lusaka is home to about, if I'm not mistaken, I don't know, but should be 3 to 4 million, somewhere there. 3 to 4 million people. You Descriptive statistics, all it does is describes your data. So you've collected your data, which is the people. It will describe this data. Perhaps maybe it will say the average income in Lusaka, or the average income made by people in Lusaka is maybe 10,000 kwacha, right? It could say there are maybe 40% of the population is male, and then 60% is female. This is you just describing the data, and then you would say something like or some, maybe these are what percentage is healthy, the other percentage is not healthy, things like that. Now, inferential statistics gets this data and then makes predictions or inferences off of it. So if we look at the data, it's 4 million people. You look at the growth rates over the past few months or few years, you can make an inference to say the population is expected or can grow by, in the next 5 years, it will probably be 6 million. You're now making a prediction based off of this data. And then you can say of that population, we expect maybe 55% will be male in the coming near future. You could also use this same data to say something about the country as a whole. So this is what Zambia, this is Lusaka. Now, it's costly for you to measure the entire Zambia, all the people in Zambia. Perhaps you want to know the average income of the people in Zambia. What is it? You just get a small part of Zambia, maybe Lusaka, and then you check in Lusaka what's the average income. Oh, it's 10,000. Then you can make an inference from that to say, okay, then in Zambia, perhaps everybody, the average income is 10,000 kwacha. So you've measured this one, then you make a prediction or assumption based off of this one to make an assumption of the entire thing. So looking at these two in detail, we can say descriptive statistics focuses on describing what has happened. Simple as that. We talk about things like the mean, which is the average, the median, which is the middlemost value, the mode, which is the most occurring value. Then we talk about charts and tables. So for instance, let's look at this. This is an example of average daily sales in a week. It's your business. This is how much you've been selling in a week. On Monday, you sold 1,200. On Tuesday, 1,500. On Wednesday, you just made a 1,000 kwacha. Thursday, 1,700. Friday, 1,900. What's your mean here? You add all these and then divide it by the number of these, which is 1, 2, 3, 4, 5. So you divide by 5 to find the weekly average. So it could be something like 12 plus 15. So I'll remove the zeros. I hope you're able to tell plus 10. I'm just removing two zeros from each. Plus 10 plus 17 plus 1,900. So this is 1,200, this is 1,500, this is 1,000, this is 1,700, this is 1,900. I've just removed two zeros from each to make the calculations easier. 1,200, 15 plus if you get 15 plus 12, or 15 plus 12, this will give you 27. 27 plus 10, that will give you 37. 37 plus 17, so 37 plus 17, it would be something like 7, that's 4, 54 plus 19, the last one you're adding is 19, this would be 3, that will be so it will be 73. 7,300. Remember, I removed two zeros, so I have to put them back. So to find the average, the total, the sum of what you've made this entire week is 7,300. But to find the average, you divide by the number of days, which is 5. So it would give you something like this would be okay, something like this. This would be your average sales in this week. Yeah, hope I'm not mistaken, but this is basically it. So the median rather, you get these values, you arrange them from the smallest, which is 1,000, to the highest, which is 1,900. Then you find the value that is on the middle. So in this case, you'd put 1,000 first, 1,200 is the next smallest, then the third one is 1,500, then the fourth one is 1,700, the last one is 1,900. The middlemost is your median, which is 1,500, is one on the middle. So the median is 1,500. So you just arrange them in increasing order. You could the mood rather is what's occurring the most. So if we had say we didn't have 1,700 here, right? We had a a 1,200 is repeating on Wednesday. So on Thursday you say 1,200 again, and then on Tuesday you also sold 1,200. Your mood would be what is repeating the most, so it would be 1,200 which is repeating twice. The rest are repeating once. But in this case, in the actual example, we don't have a mood here because there is nothing that is repeating. But if we add something like what I've put down here, the repeating would be 1,200, so it would be your mood. And then you have charts and tables. That's descriptive statistics. It just looks at what has happened, what's the data, then tries to talk about the data, the what, the middlemost, your average, your mood, things like that. Inferential, like I was explaining in the previous example, it goes beyond data to make predictions or generalizations used when analyzing a sample to understand a larger group. So what I was saying was, if you have Zambia, can't measure the entire Zambia. You want to know how much everyone makes. You just measure people in Lusaka, maybe a few people in Lusaka, a few people in Ndola, a few people in Kitwe, a few people in Kabwe, a few people maybe in Livingstone. You measure those, then you can assume from those that, oh, perhaps it's the same for everyone else in Zambia. That's inferential statistics. It gets data and then it makes inferences or generalizations about that data. An analogy is tasting a spoon of soup to judge the whole pot. So if you want to know if there is enough salt in a pot, you don't go and test the entire pot. You check every corner of the pot, every single drop of soup to check if it has salt. You just take a little bit. That tells you about the rest. So once you taste, if it has a lot of salt, you say, okay, my soup is salty. If it doesn't have salt, then you say, okay, my soup doesn't have salt. So you are checking just a bit to tell the story about the rest. So an example is predicting next month's sales based on last month's data and seasonal trends. So seasonal trends, these are things that I was explaining in that example where I was describing ice cream sales. You look at your sales in different seasons and then you can make predictions. Oh, okay, in this season we normally make this, so we are going to make this. It's like that. So we can do a comparison table, descriptive, and I'll put vessels there because these are two different. They're all statistics, but just two branches of statistics. So descriptive, the purpose is to describe data. Inferential, make predictions. Descriptive takes the entire data set. If you are measuring people in Lusaka, you want to know how many female and how many male are in Lusaka, you would study the entire Lusaka. But for inferential, you could just study a few areas in Lusaka. You take perhaps Ibex, take Kalundu, uh, take something like I don't know, Kanyama. You could take Matero, you could take Lilai, you could take Livala. Just those, maybe those five. And then from those five, once you measure them, find how many people are living, you could generalize and say, okay, it's the same for the entire Lusaka. So those is just a sample. You've taken a sample out of the whole. This is the whole Lusaka. You take one compound, one area, one area, one area. So this will be your sample. These two compounds. You study them, then you assume it's the same for the entire Lusaka. So our examples include for descriptive, average sales per week. For inferential, predicting future sales. So this is just to get you thinking a bit. Think about this. Uh, like I keep saying, most of these courses are very simple. They are very simple. The only challenge is that most of the things that you are learning, for instance, the words, the terminologies, are new. You've never heard them before. They are not in our mainstream English vocabulary. There are things these guys, statisticians, made, so they sound new, they sound complicated, but in reality these are just things that we experience on a daily basis. It's just that they formed to my words for them that make them look unique or superior and things like that. But really, statistics is in your life. It happens in almost everything you say. I know you've mentioned something to say on Mondays. You normally rest. It's a day of resting. How did you come to that generalization? You looked at your past few years, maybe 5 years. You saw how you behave on Monday, and then that helped you form a generalization about your Mondays, even your future Mondays. You're able to tell, okay, this Monday it will be like this. That's statistics in play in your life. You will also monitor your study hours. You tell, for me, okay, I study per day, I'll study for 3 hours. After 3 hours, the rest I'm just lying to myself. It doesn't enter after 3 hours I'm done. How are you coming to that conclusion? Because you've studied your past behavior. That is statistics. You could also track your monthly spending patterns. You see how you've been spending money over the past few months. That will tell you about how you spend money. That is statistics. Some people even count their social media likes or engagements. You post something, you check in the morning how many people have liked it. In the afternoon, how many people have liked it. In the evening, how many people have liked it. You are tracking your engagement. Some people off of that, they'll feel okay, I'm popular. Some people perhaps maybe what I don't know. Some people feel depressed. It happens. I don't get how, but it's the case. These things happen, and that's statistics in life. It happens in everything that we do, every single thing that we do. You could also record your daily customer visits in a small shop. So if you own a shop, you're seeing how many people working every day. You'll be able to tell, okay, on Mondays, I don't get too many people. They are working. But on Fridays, a lot of people visit my shop. So as you are making a decision on how many people to hire, you would want perhaps maybe to hire more manpower to help you over the weekends when you have most customers because you've taken the time to apply statistics, to check, and it has given you an informed decision to hire people over the weekends because that's when you have a lot of foot traffic in your shop. It could be even at church. You'll be able to tell, okay, this Sunday we didn't have too many people. This Sunday we had so many people. That Sunday, even prayers throughout the week, you tell Monday this number of people came. Tuesday. So statistics happens in almost every single thing that we do. So to get you remain thinking about this, you can perhaps look at this simple quiz. Just think about it. Um, ponder upon it a bit, get to assess yourself. Just check, ask, okay, what is statistics? What are the two types of statistics? Give one example of each. But this is basically statistics. This is what we'll be doing as we dive deeper into this course. But this was a very, so you can pause on this page. This was a very simple discussion on what statistics is. So our next session will be on data collection and presentation. How do you collect data? Where does data come from? And how do you present it? There are some methods and things that we employ in statistics to go about everything. But we will look at those in our next session. So thank you very much for your time. I do hope that you get the time to go through this simple introduction. I wanted it to be an hour, but I think this time is it's enough. It's now about 33 minutes, which is fine. I think so. Yeah. So because this is a numbers course. Literally, it's a numbers course. There won't be many discussions like this. Just an introduction, just explaining what will be expected. But as you've seen, even from the introduction, there are parts where I was writing numbers and things. This is a numbers course, so it's best uh, done perhaps even in physical. If we have those physical sessions, we'll be doing much of this. We can also do some online sessions where necessary. Yeah, that's where we are interacting. Get to ask me questions or add something as well so that we are able to move together. But this was a simple recording just for your own. I know you are busy moving up and down and things like that. So when you find time, you can at your own convenience, you can go through this video. It will introduce you to what statistics is all about and why we should learn this course. So once again, thank you for your time.